Today we're talking about all of your statistical applications. That's correlation, that's chi-square, that's goodness of fit, that's your t-test, Spearman's rank. All of them fall into your statistical application. So we're going to refresh your memory of all of those different tests. This was during our quarantine time, so I got a little bit more detailed of a review just to make sure, because I know that was kind of a rough time for us. We're going to start off with correlation. Correlation determines the strength of a relationship, okay? So anytime you say the word relationship, especially like in your IA, you're implying correlation because it compares to, it looks to see if two variables are related to each other. It is found using your calculator, even though there is a way to do it by hand. And you're definitely going to need your calculator for today. So if you could go ahead and pull that out. So then that way, when we do our different examples, we're ready to go. This was the breakdown. R represented our correlation coefficient. If R was in between 0 and 0.25, the absolute value of R, of course, then it meant that the relationship between our two variables was very weak. Between 0.25 and 0.5, it meant that it was weak. And essentially, the relationship was pretty much, there wasn't one, if it was weak or very weak. In between 0.5 and 0.75, there was a moderate relationship. So there's a possibility that there was a connection between the two. And then of course, if it was between 0.75 and 1, then the relationship was strong, okay? So the relationship was strong. Along with correlation, when it's calculated using your calculator, you also find your line of regression, okay? Your linear regression. It's also called the line of best fit if you do it by hand, okay? What's the difference between them? Well, there's a big difference. A linear regression is a more exact, it's more of an exact line that compares your data versus your line of best fit, which is something that is done by eye. You may be asked to draw a line of best fit. So if you are asked, you need to do two things in order to draw it. You want to find the mean of your X data and the mean of your Y data. So you want to find your X bar and your Y bar because you're going to plot that point, okay? Once you find that X bar and that Y bar, you're going to plot that point, and then you're going to draw your line of best fit through the mean. And so that half of your data is above the line and half of your data is below the line. With your linear regressions, this is important. This is definitely for any of y'all who are doing a statistics-based IA or even in the test. You only find a regression line when the correlation is either strong or moderate. You don't use it for a weak or a very weak relationship, okay? Because your line of, your regression line is essentially used for not approximations, predictions about other potential data that you could possibly collect, as long as it's within the data that's already given to you, okay? We talked about two different words last year, an interpolation and an extrapolation, okay? An interpolation was when you, let's say, you had your data already, you found your correlation and your regression line. An interpolation was a value that was within the other data values that you were given. So let's say your data went from like 0 to 100. An interpolation will be within that range, but an extrapolation would be outside of that range. So, if the value was 130, that would be an extrapolation. Even though you could make a prediction, the fact that 130 is outside the range of the rest of your data, it technically, it wouldn't be accurate because we don't know what could potentially happen after that largest data value. The calculator process that went behind this, okay? You were definitely using stat a lot because that's where you had to actually type in your data values. Okay, so when you press stat and then we would go to edit, remember we would type all of our information into L1 and L2 because we would have two different variables here. And then once we got our data in, we will want to press stat again and then go over to calc and access linreg. Linreg is where we would go to get our correlation coefficient as well as our linear regression line. If you notice, there's two linregs. Does everybody see that at 4 and at 8? To be honest, don't use 8. Because if you look at that form, it was A plus BX. You know, we're used to writing lines as Y equals MX plus C. So it's better to use option 4 versus option 8. Is everyone following me? If you use option
Yes.
8, if you use option 8, I mean, just know you're gonna have to switch them, all right? Once you went to linreg in option 4, you know, you had your X list was L1, Y list was L2. You always want to make sure that your frequency list is empty as well. So there should never be anything in your frequency list when you're doing linear regression, trying to find correlation, okay? Something could pop up in that frequency list if you did maybe some basic statistic stuff before you got there. And so you always want to clear it out when you're doing any correlation, linear regression, and things like that. You don't necessarily have to do this part. So don't, to be honest, don't even worry about this part, okay? Don't even worry about storing it. Don't even worry about storing it. Semi and y'all who have like the more simple, or not simple, but older calculators, you're not gonna get these options. So you have to do L1 comma L2. Then you would go down to calculate and get your respective answer, okay? So let's look at an example. Remember, I am recording. I'm not expecting you guys to write down these examples. You can go back and write them down if you would like. This is more so just refreshing your memory. A survey investigated the relationship between the number of cleaners N and the amount of time T it takes for them to clean a school. So we have our different cleaners and we have our time. It says use your graphics display calculator to write down the equation of the regression line T on N. T is our dependent variable, N is our independent variable. But if it tells us how to write the equation, it should be T equals some number N plus or minus the other number, okay? Make sure that you do that. I don't want anybody to lose any points because you decide to use Y and X. So I need to go into stat, I need to go into edit, and I need to type in my data. You guys should be doing this along with me to make sure that you're getting that muscle memory back. 1, 2, 3. Remember, after each entry, we press enter. And then what buttons do I press to get my linear regression? I go to stat, calc, option 4, linreg. And yes, as long as you put your X's in L1, your Y's in L2, then you won't have to ever worry about changing that at the top. It automatically populates. My frequency list is empty. If yours isn't, you need to clear it out and then go down to calculate. And then there we go. We have our linear regression and we have our Pearson product moment correlation coefficient. That is the full name for the correlation coefficient. If you use that in your IA, please make sure you use the full name. Pearson's product moment correlation coefficient. So rounded 3 significant figures. What's my A?
20.1.
Negative 20.1. And then my B would be plus
205.
Very good. So there is my linear regression line, T on N. My Pearson product moment correlation coefficient is R, not R squared. Remember, R squared is the coefficient of determination. We really don't even use that for our exams. It's just R. So that's going to be negative 0.941. Thank you. 0.941. Then it says to use your regression equation to find the amount of time 4 cleaners take to clean the school, because if you notice 4 was missing from the data. And so we can use our regression equation to find that. If you happen to get the regression equation wrong, still use that equation, because you could get follow-through points because you knew that you were to plug it into your regression equation. Am I plugging it in for T or am I plugging it in for N? For N. Very good. And so I use the equation. We do use the rounded because that is the equation that we wrote down, and we get our respective answer of how many cleaners? Or not cleaners, sorry, time, 125 minutes. Yes, this would be like a question 1 or a question 2, okay, on paper 1, because it's a short response. It's pretty straightforward, pretty simple. The one thing is, though, you guys, is that when you sit for your test, your calculator's memory is going to be reset, which means when you go through the process of getting your linear regression equation, you're not going to get your correlation coefficient. And this is why. Memories get reset for your test. And so when you go in, your table's going to be empty, which is fine. I mean, your table needs to be empty anyway whenever you're doing any type of statistical, whatever. But look at what happens. When I go to LinReg, that's exactly what's going to happen on the day of your test. If you forget to turn on your diagnostic, you need to make sure that when you sit for that test, you turn on your diagnostic and you set your mode to degree, because radian's the original default mode when you reset your calculator. Okay, so there's going to be 2 things. I'm going to remind you the day of the test, but I'm telling you this now. So how do I turn my diagnostic back on? Some of you guys have the option to go to mode, and for me, it's in blue. It says stat diagnostic. It's off. I need to go down there and turn it on. So mode, stat diagnostic, make sure that's on. Okay. Some of you guys don't have that feature, so what you're going to have to do is you're going to have to press the 2nd button and then the 0 button, and then you're going to also press the this X to the -1 button that has the D on top of it. So then that way you can scroll down to diagnostic on and click enter. That way, when you go back and do your linear regression, there's your correlation coefficient. This one here is an example of doing the line of best fit. Consider the following values of X and Y and the scatter diagram, which represents the information in the given table. Got a lot of data. It's not in, well, yeah, actually the X's are in order, okay? It says we have to write down the value of A and we have to write down the value of B, okay? Write down. Anytime you see those words, it means it's little to no work. Answer staring you right in the face. What's the value of A?
8.
It is 8. It is the Y coordinate when X is 1. If you notice, there's 2 points when X is 1. 5 is this one. So the other one had to be 8. And then what's the value of B?
3.
Not 3.
Five.
We actually have that point already there. It's actually going to be 5. So there's actually 4 points, not 4 points, 3 points where the Y value is 4. There's the 3, here's the 7, so we needed the 5. And I know it's, if you actually could, hold the paper and touch and cross out, I know, it'd be easier working what we got, okay? Now it says the mean of X, the X values is 5 and the mean of the Y values is 4, okay? That's actually one of our points in our scatter diagram. When X is 5, Y is 4, is actually that point where we found B. We have to draw the line of best fit. I don't know if you guys remember, but anytime you draw the line of best fit by hand, you plot the mean point, you circle it, and then you label it. Majority of the time, you'll label it with a capital M, but if they tell you to label it with a capital P or a capital Q, you do it how they tell you. But anytime you draw the line of best fit by hand, you plot the point, you circle it, and you draw and you label it with a capital letter. Now my line of best fit needs to go through the mean point. Half of my data needs to be above that line. Half of my data needs to be below that line. You do your best here. You are given rulers. You are given pencils to do any of your drawings. So, if you make a mistake, you can erase it and try again, but try to get on the first time with your ruler, okay? So, but use that straight edge to help you. 1, 2, 3, 1, 2, 3. Okay, so I'm probably looking at something like this. I got 1, 2, 3, 4, 5, 6, 7 points above, 1, 2, 3, 4, 5, 6, 7 points below. So that's a pretty good line of best fit. And on top of that, I'm intersecting my y-axis. Make sure your lines of best fit, when they're drawn by hand, intersect the y-axis as well. But however you draw your line of best fit, use your line of best fit, if it tells you to estimate your y value when X is equal to 6.5. So I go to 6.5 on my x-axis, draw my vertical line up, then draw it over. And so my estimate based off of my line of best fit would be roughly 2.8 for my y value, okay? I might even could go with 3 if I actually drew a straight line, like I used the actual like the line feature, it probably would have been closer to 3, but I use my line of best fit to get an estimate. Yes, they'll have a window of acceptable answers because we are drawing this by hand. Last one we'll do a correlation. All these questions I pulled, they were old IB questions, old ones, all paper 1. A lot of them were like in the first 7 questions because they've all been pretty easy, okay? Statements 1, 2, 3, 4, and 5 represent descriptions of the correlation between 2 variables. Which statement best represents the relationship between the 2 variables shown in each of the scatter diagrams? Take a moment, match A, B, C, D with 1, 2, 3, 4, 5. All right, Christian, what's A?
That is low positive linear correlation.
Very good. It is a low positive linear correlation. Okay. First off, correlation is only dealt linearly. So if it's forming with potentially going in like a linear direction, it's a linear correlation, and it is low compared to being high. Low basically means a weak correlation or a very weak correlation, but it's still heading in an upward trend. It's still heading in an upward trend, hence positive. So yes, very good. Okay. Let's see for B. Julia, what'd you get?
I put low negative.
Okay. Remember, low would mean weak. Okay, which means that your data will actually be kind of more spread out. And it looks like it's kind of squished in. So yes to the negative, but it's actually going to be
High negative.
high negative. Okay. All right. If I were to draw my line of best fit, my data is very, very close to that line. Unlike in 2, where it was a little bit more spread out. For C, Semi, what you get?
I said no correlation.
Very good. There's not a particular pattern between our data. It's not heading upwards or downwards like it was in A, B, and even in D. Yes, there's no correlation. No correlation would mean that R is equal to what number? Anyone?
0.
Exactly, equal to 0. Because 1 would mean a perfect correlation. Either 1 or -1 would be a perfect correlation. And then for D, Guyena, what did you get?
High positive linear correlation.
Very good. It is heading in an upward trend, so it's positive. It's very close to the line, so it is high. Very good. Questions on correlation? So as we proceed, let's talk about Spearman's rank. Spearman's rank is very similar to correlation. It actually uses the same symbol that we use for correlation, just the difference is it would have a subscript of an S. That's how you know you're dealing with Spearman's rank versus Pearson's product moment correlation coefficient. But like I said, it's done the same way that we do correlation, except instead of using the actual raw data to type into our list, we use the ranks instead. So that means we look at all of our data for our X's, all of our data for our Y's, and we literally list from highest to smallest value, okay? Spearman's rank is used to show the extent to which one variable increases or decreases as the other variable increases. So that is the purpose of Spearman's rank, to see if a variable is going to increase or decrease as another one increases. So the closer that our Spearman's rank is to 1, that means our data is more likely to increase. The closer our Spearman's rank is to -1, that means our data is more likely to decrease. And the closer it is to 0, that means it's going to be neither increasing or decreasing, which literally means that there's like your data is like pretty much scattered to the wind. One note, do not rearrange the data. Okay, put it into your list exactly how it appears in your table. So exactly how the ranks appear in your table is exactly how you're going to type it into your calculator when it gets time to type it in. So don't rearrange it. So let's look at an example here. This is a long one. This will be an example of a paper 2 type question. Paper 2 are your long response questions, your A through G's or your A through F's. All right. You're probably going to have about 5 to 6 of those on your actual exam. The Elite Traveler and Nash Traveler are 2 magazines that review and rank the best restaurants in Paris. Based on different sets of criteria, scores out of 10 are assigned to 8 restaurants in Paris labeled A through H. The raw data is collated in the following table. We have Elite Traveler scores, which are X, Nash Traveler scores, which are Y. We're going to find the Pearson moment correlation coefficient R for this data. So that means I need to type it in. Everyone should be doing this example along with me to make sure that we are capable of getting these values, these numbers.
What was the command to bring back L2?
You deleted your L2?
I deleted it.
Okay, that's all right. Let me type in the rest of this. Let's say you accidentally delete one of your lists. Does that have an effect on anything if I delete a list? It could. You just gotta, it's better to have it. So you wanna press clear, enter to clear the list, but if you accidentally press delete and it's gone entirely, what you do is you go to stat, you go to option 5, and you click enter. And so it's essentially setting everything back up. So when you go back to edit, your L2 is back. So stat 5 brings back any list that you accidentally delete. So once you get your data in, remember to get correlation coefficient. I press stat. I go to,
Calc
very good. And then I go to option,
4.
good. L1 is my X's, which is labeled. I put elite in L1. I put NAST in L2. Nothing in my frequency list. And I go to calculate. Remember, for the older calculators, L1, comma, L2. And there's my R. Rounded to 3 significant figures, it should be point. Hello.
Oh, sorry.
0.961.
Thank you. 0.961. Now it says use the value of R, interpret the relationship between elite traveler scores and Nash traveler scores. Interpret the relationship. That means that value of R is weak, very weak, moderate, strong.
Very strong.
Strong.
It's strong. But you just don't want to say strong. You're talking about the relationship between two different magazines. So interpret in context of the problem, the relationship between the two magazines is very strong. And if you want to, you can even say, and positive. What does that mean? That means as elite traveler scores increase, so do Nash traveler scores increase. Okay? Because your data is forming a positively strong relationship with one another. Even say that as well. My linear regression, y on x, is going to be y equals
0.685
x
plus 2.38.
Very good. I find my linear regression the same time I find my correlation coefficient. Now it says use my regression equation, whether it's right or wrong, from part B to estimate Condon's Nash traveler's score when elite travelers awarded a perfect 10. So elite traveler was X or Y?
X.
Y.
X.
X. So when elite traveler gives a perfect score of a 10, that means I have to plug 10 in to my X. So go ahead and plug 10 into this equation, please, and tell me what NASA's traveler's score is.
I got 9.23.
9 point what?
23.
23. Confirmation?
I got that too.
Good stuff. So, is this estimate reliable? Yes or no, and justify your answer.
Yes, because it's very close to 10, and because we had a very strong positive relationship.
Even though we had a very strong positive relationship between the two, because 10.
Oh, because 9.3 and 10 are close to get, like, they're close numbers, maybe that's why it's reliable.
Even though they're close, the largest X value was 9.7. 10 is larger than 9.7. So even though it's very close, this data, our regression line was based off of the fact that the highest score was at 9.7. So 10 is actually outside of my data values, outside of that range. And so it's actually an extrapolation. So it's not reliable. It's not reliable because you can say extrapolation. That is the word that's used, and everybody, everybody in the IB world knows that that means my data value lies outside of my range, but you can also say that 10 is outside of the range of 5.6 to 9.7. In part D, I have to complete the 2 empty rank rows in the table above. Okay, you start with your largest, you go all the way down to your smallest. So on my X's, A through H, which one is the largest? Promise not a trick question. Which X value is the largest? 9.7, so that gets a rank of 1. What's my next largest?
8.8.
So that's number 2. Keep going.
8.3.
Followed by,
7.5.
good, followed by,
7.2.
yep, 6.9.
6.7.
Good, and then the last one's 5.6. Wonderful. You do that again with NASA's traveler's rank. My highest is
9.3.
followed by
8.0.
8.0. No, 8.2.
8.2, then 8.0,
Then 7.7.
7.7. Just because your X values have a particular rank order doesn't mean your Y's are going to follow. If they do, that means your Spearman's rank is equal to 1. If all of your ranks are the same between your X's and Y's, you already know Spearman's rank is going to equal 1 because they line up together. What's the next one?
7.2.
Very good. Now, the next one we come to is 6.9. You see how 2 of them have the exact same value? When that happens, we have to take the average of the next one, okay? So my next number is supposed to be 6 when I rank it, but technically 6 and 7 is shared between B and C. So whenever values share a particular rank, then you take the average. So then it's going to be 6.5 for both of them. So whenever data values are shared, or ranks are shared, I'm sorry, then you take the average between technically the 2 ranks that they would have taken. And then that means the last one is going to be 8, not 7, but 8. It's just like in a competition, okay? Like in a race, when people tie and points are awarded, basically they split the points because they came in at the same place. Sure. Now we're able to find Spearman's rank correlation coefficient by actually plugging in our data values into our L1 and L2. Remember what I said on the other slide. I don't change up or rearrange their placing. I'm literally going to put it in exactly how it's ranked on the board. Oh, dang. So y'all should be doing the same. L1, I'm going to put the ranks for elite. L2, I'm going to put the ranks for Nash. .5 because those 2 happen to share that rank. And I find Spearman's rank the same way I find correlation coefficient. I press stat, I go over to calc, and I go to option 4. The same way I would do to find my correlation coefficient. The only thing that's different is the fact I'm using the ranks, not the actual raw data. So my Spearman's rank coefficient is 0.970. That value is very, very close to 1. Remember what I said earlier, Spearman's rank is 1. That means that we're going to be what?
Positive correlation. Strong correlation.
I mean, it is a strong correlation, yes. But what does that also mean? The closer that it is to 1 means my data is increasing, okay? Not my data. Or one value is increasing as the other one is increasing as well.
Can we put X is increasing or
Yes.
Y is increasing as X is?
Yes. The director of Elite Traveler magazine believes the score for restaurant E was too high and decreased the score from 7.2 to 9.2. Explain why the value of Spearman's rank correlation coefficient does not change.
The ranking is still the same.
Exactly. It doesn't change. Because the rank didn't change. Questions on Spearman's rank? Chi-squared. Chi-squared was one of our statistical tests that was done with Tata. We were trying to figure out if one was dependent on the other. There are 4 main steps. 4 main steps. You write out your H naught and your HA. They stood for your null hypothesis and your alternative hypothesis. To be honest, in the actual test, it's going to tell you to write out one or the other, or they may even give you your null hypothesis. If you're planning to do chi-squared for your IA, you should write out your null hypothesis and your alternative hypothesis. After you write it out or after it's given to you, you want to calculate your chi-squared test statistic. And of course, I'll show you, refresh your memory on how to do that. In step 3, you want to calculate the critical value. Step 3 is actually something that you don't do on an actual IB exam. They'll either give you your critical value or they'll give you your significance level. If you're going to be doing chi-squared for your IA, you are going to have to use the chart that we gave you guys last year that showed the distribution. And you'll have to find your critical value using the table, using your significance level and your degrees of freedom. However, this lesson today is about test stuff, not IA stuff. So if you are doing chi-squared and you have a question on how you calculate the critical value, make sure you message me individually. After you have your chi-squared test statistic and your critical value or your significance level, you would compare your chi-squared to your critical value or your p-value to your significance level to determine if you're going to accept or reject the null hypothesis. So step 1, you do your null hypothesis. I put this here to make sure everybody understands this. Do not stray away from this setup. This is how you should write your null hypothesis. Blank is independent of blank. Whatever your dependent variable goes first, and your independent variable goes second. Do not stray away from this setup, okay? If you start saying, oh, shoe size is associated with age, don't change up the formula, follow it that way. You will not lose any potential points, because the mark scheme will say, do not accept these words or these phrases. Just stick to blank as independent of blank, whatever your variables are. Your alternative hypothesis, blank is not independent of blank. Don't stray from it. Keep it to this formula. Step 2, this is where you type your data into your table. All right, in your calculator, you're going to be going back and forth between the second button and the X to the -1 button. Because when you press the second button, the X to the -1 button, it pulls up this these options for you, these matrices. You go over to edit. That's how you edit your matrices. Then you'll have to actually type in the size. It goes rows by columns, okay? Rows by columns. You'll type in however many rows you have, how many columns, and you'll fill in your data. Once you get all your data filled in, you go to stat and you go over to test. Chi-squared is located at C, option C. And as long as you have your original observed data values in matrix A, you don't have to worry about putting anything in matrix B, because it's going to be automatically calculated once you calculate your chi-squared. Okay? So second X to -1 and edit, that's where you type in all of your data values from your table. But then stat and test is where you actually will calculate your chi-squared test. And if you notice too, that's also where your goodness of fit test is when we get to it as well. A side note on step 2, expected table is found when you perform your chi-squared test. However, you may have to show how you get a particular expected value. This is the formula of how you actually find your expected value. It's your row total times your column total divided by your overall total. And you'll see what I mean when we get to an example. Okay, you see what I mean when I say row total and column total. But that's how you actually find the expected values that are found in the table when it's actually calculated. For those of you guys doing chi-square for your IA, you are going to have to do this part by hand. And so when we get to that one example, you're going to have to do this for each one of your table entries. Step 3, this is where you look at your critical value or identify your significance level. Critical values are always given to you on your test. However, if it's not given to you, then you'll know the significance level. Either way, you'll be able to do step 2. So step 3, take your critical value or your significance level and get ready to compare it to your chi-squared test statistic or to your p-value. Because in step 4, that's when you accept or reject your null hypothesis. Get this down. You need to know when you accept or when you reject for both the chi-squared test statistic and for the p-value. If the chi-squared test statistic is less than the critical value, you accept your null hypothesis. If it's greater than your critical value, you reject. So you compare your chi-squared test statistic to your critical value to accept or reject your null hypothesis. But if you're not given a critical value, you'll have to compare your p-value to your significance level. You find the p-value the same time you find your chi-squared test statistic. If the p-value is less than the significance level, then you reject. But if your p-value is greater than your significance level, you accept. Again, you need to know this. Some other important information for your Chi-square test, you may be asked to find your degrees of freedom on the actual exam. That is found by taking your number of rows and subtracting 1, and then multiplying it by your number of columns and subtracting 1. So that's how you find the degrees of freedom. They may ask you to do it on the test. It's strictly, you know, those are 2 easy points right there. For your IA, you do need this number along with your significance level to determine your critical value for accepting or rejecting for your actual IA. So let's take a look at this example here. A group of 100 students gave the following responses to the question of how they get to school. You got males and females, and then their method of getting to school: walk, public transportation, car, or bike. In total, you got 100 results. A chi-square test for independence is conducted at a 5% significance level. The null hypothesis was defined as the method of getting to school is independent of gender. Do you see the structure of your null hypothesis? You need to follow it. And also, your dependent variable, the method of getting to school, and then your independent variable is gender. Think about it. It can't be the other way around, because the method you get to school, like that can't stand alone. It's going to be whether you're a male or female and determining whether or not you're getting to school. Okay, how you're getting to school. Okay. Find the expected frequency for females who use public transportation to get to school. Females who use public transportation, females who use public transportation is corresponding to that number right there. So when you're finding expected value, remember that formula was you take your row total and you multiply it by your column total, and then you divide it by your overall total. You need to identify where that value is going to be located, because you need to take that row total, which is what number? 48. You multiply by the column total, which is
30.
And then you divide it by your overall total, which is 100. That is how you find your expected value or your expected frequency. My mistake. That number will be calculated once we perform the chi-square test in our calculator. But if you ever have to show it, find it, that's how you do it. Now let's calculate the chi-squared statistic. Remember, we go to second, x to the -1. That's how we get to the matrices. We go over to edit and we click enter on A. That's where we put in our observed values. How many rows are we going to have? How many columns? 2 rows.
4 columns.
Now 4 columns. So it should be set up the same way that our main data is set up, okay? Our main data, no totals, no totals. Is everybody still with me? Let me know if I've lost you at any point. So I start typing in my values: 18, 13, 14, 3. Click enter after each one. Yes? Now this is important. A lot of times when we do things in our calculator, after we've typed in our data, we usually just go straight to the test. Quit out of this, okay? Press second mode and it takes you out of that program where you just typed in your matrices, okay? Second mode. Now perform your test. You go to stat. You go over to test. And remember, chi-squared is option C. When you click enter on C, the data that you just typed in is in your A matrix. Expected will show up in your B matrix once we actually calculate. Color, don't worry about that if you have that option. Just go to calculate. And there's your chi-squared test statistic. There's your p-value. There's your degree of freedom. Okay? So my chi-square test statistic round to 3 significant figures is what?
Oh, 12 point, oh wait, 13?
Just 13?
Yes. 13.2.
It has to be 13.0. Don't forget, anytime you have to round up to the next whole number, you need to put that 0.0 there for your 3 significant figures. Now, luckily, we're given the critical value to be 7.815 at a 5% significance level. If the critical value is not given to us, we would need to use the p-value and test it against the significance level. But since we are given the critical value, compare it to the chi-square test statistic. Am I going to accept or reject?
Reject.
I'm going to reject because the chi-squared is more than the critical value. 13.0 is greater than 7.815. That is the reason of why we are going to reject our null hypothesis. The comparison of the values is the reason. And then of course, a saying if we're going to reject or accept is answering the first part. You cannot get your R1 or you cannot get your A1 without getting your reasoning. So as long as you compare, you'll always get that point. And then you just got to remember when to accept or reject. Everyone good?
Yes.
Yes, ma'am.
Then I want you guys to try this one on your own. Okay? Don't worry about writing down the whole problem. Just go ahead and start writing down the null hypothesis, finding, so on and so forth. So, Hunger Games. A producer of a TV dancing show asked a group of 150 viewers their age and the type of Latin dance they prefer. The types of Latin dances in the show are Argentinian tango, samba, rumba, cha-cha-cha. And the data obtained were organized into the following table. No totals, just your raw data. A chi-square test was carried out at a 5% significance level. So write down the null hypothesis. What did you guys say?
The Latin dance is independent of age.
Latin dance is independent of age. Very good. Age is your independent variable. Type of dance is your dependent variable. Perfect. Blank is independent of blank. Very good. Part B was pretty straightforward. You had to write down the observed number of viewers who preferred Roomba and were older than 20 years old. Somebody online, what number did you get?
18.
18. You were literally pulling that from the table, making sure you could read the table. Then it says use your graphics display calculator to find the p-value. Remember, p-value is found the same way we find our chi-squared, okay? So who got that answer?
P-value is
Wait, online. Somebody online.
0.087. Wait, 0.088.
0.08. How many significant figures is that? Like what I have shown right now.
Is it only one?
It's only one. So I need to go 2 more. Remember, significant figures, we start with our first non-zero number and then we make our count. So this is my number.
0.0876.
Should be 0.0876. So be very careful. Don't lose that rounding penalty. Now, the producer claims that the type of Latin dance a viewer preferred is independent of age. So they basically made the claim that their null hypothesis is, like they were the ones who came up pretty much with the null hypothesis. They claimed the type of Latin dance a viewer preferred is independent of their age. Is this claim justified? In other words, do we accept this claim? Or do we reject it? What did you guys say?
You accept it. Because the p-value is greater
Well, online,
Except
and why?
because the p-value is greater than the significance level.
Because the p-value is greater than the significance level. Did you compare the values? Or did you just say the p-value is greater?
What do you mean?
And did you actually do the numerical comparison, or did you just make the statement?
I made the statement.
Okay, so the statement provides the reason supported as well with the numbers. So yes, it is justified. Yes, we accept that null hypothesis. We accept that claim because the p-value is more than the significance level. Put that there as well. Doesn't hurt to compare the values as well. And that is how you do our chi-squared test. That's how we do chi-squared tests. Now we still have goodness of fit and t-test to go over, but we'll save that for next class. But this is so far a lot of the statistical applications that you guys have learned about in this course.